In this Symfony 2 introduction course, we will see how to build a block from scratch, using some of the most important features of the framework. Among them, we can highlight, for example, the MVC pattern, Model View Controller, where the framework itself helps us to modularize the code, the concept of bundle, which is a new name to designate the old plugins, with the difference that now everything is a bundle, even our own code. This way, the framework helps us to reuse components, which can be common in multiple projects. Generators, which help to create the basic structure of the different modules for our application. The integration with databases through Doctrine 2. The integration with PHP Unit for unit and functional tests. In fact, we are going to develop following the TDD philosophy, test-driven development. The Forms framework, validation of the data entered by the user, security through firewalls, and the authentication and authorization system integration, IAC10N or internationalization, and the service container, whereby we can modularize the code in services and inject the needed dependencies. To follow the course, we will be using three things: a terminal or command line, an IDE, and a browser. I recommend to use an IDE with PHP support because we will need to set namespaces constantly, and the autocomplete feature will be helpful. I recommend a specialized IDE like PHP Storm, although there are good alternatives such as NetBeans or Eclipse for PHP. Since Symfony 2 is a PHP framework, we need to have it installed, preferable version 5.3 or higher. I recommend to install the latest available version, since it will provide us with features that will make our work easier. In version 5.4, we have an integrated web server, so we don't need to deal with virtual hosts. In version 5.5, the integrated then op cache, so now it's not necessary the installation of other PHP accelerators. Let's make our development environment ready. In my case, I use OS X, so I will be using Homebrew. In order to install it, I will enter this command in the terminal. To get the Homebrew formula for the most recent PHP version, we must access this GitHub repository and follow the instructions. Before doing this, it's necessary to install Xcode command line tools, but with Mavericks this step is already solved, since it will install them automatically through this window. If we go down until Usage, we'll see the Homebrew commands to configure the required formula. With this, we can configure the required options to install the packages. And finally, we install PHP 5.5. It's also very important to follow the Symfony 2 coding standards, which are based on PSR0, 1 and 2 PHP standards. It's intended to describe structure and style for code and comments, to make teamwork much easier. To follow the standards, it's necessary to install the PHP Code Sniffer library, and to have a compatible IDE such as PHP Storm. Once PHP Code Sniffer is installed, we visit this GitHub repository, where they give us a guide to install the Symfony 2 coding standards. In my case, I use Homebrew, and I'm going to clone the repository in this route. At this moment, I need to install some more dependencies, for example Xdebug and INTL. To do this, we are going to use the Homebrew search tool, searching for PHP 5.5. Now I'm seeing that PHP 5.5 Xdebug is the formula I'm searching for. and I'll do the same for INTL. Now I'm setting it as the default standard. And we are ready! Woohoo! To install the framework, we'll use Composer, the dependency manager for PHP that controls our library versions. I'm going to install it with Homebrew, through the Composer formula. And next, I'm going to update it to the latest version available on GitHub. Before moving forward, I recommend you to read the first 3 chapters from the official book. It will help you to understand the basics and framework philosophy. We are going to create a new project with Composer, using the Symfony standard distribution, and specifying the latest available version, which in this moment is 2.3.6. We'll call the project Symfony 2 block. After installing Symfony 2 on all its dependencies, the system is asking us some default parameters. We'll accept all of them. First is MySQL through PDO, database host at localhost, default port, database name, which we are going to change to Symfony 2 block, default database user and password, and default mailer. Default language will be English. Finally, it is asking us for a secret token, which will be used by the framework to generate some things, like for example CSRF tokens to protect forms. But since this application will not be deployed to production, we'll leave it as it is. The framework is now installed. We are opening the project with our IDE. If you use PHP Storm, we are going to configure the preferences to make the development easier. First thing is to disable spelling to avoid marks that distracts us. Let's write spelling here. Enter into inspections, disable spelling, and apply. We'll configure the ignore directories. To do that, we'll remove what we searched for. Enter into directories, and we'll ignore cache and logs. Apply, so that they will not be included in searches nor autocompletes. Next, we'll select the PHP interpreter. Go to PHP, choose the latest installed version, 5.5, and choose its location. In my case, I have it already configured. In name, I wrote PHP, I set the Homebrew PHP root, and automatically it detects the correct version with Xdebug activated. I press OK, and now I have it selected. Finally, we specify the PHP code sniffer location, and we validate it. To do that, I'll search for sniffer here. Here I have it already configured. It's where Homebrew installed it. I press validate, and it's successfully detected. Next, with sniffer written in the search box, we go to inspections and we activate PHP code sniffer validation. Here, in coding standard, we have to select Symfony 2. Let's update the list so it detects which ones we have and we select Symfony 2. From now on, it will validate the Symfony 2 coding standards. And we are now ready to start. Let's enter into the project directory to check if the Symfony 2 console runs correctly. These are all the Symfony 2 commands. We are going to start the web server that comes by default in PHP 5.5 through the Symfony 2 command server run. As we see, it's giving us the URL localhost port 8000. Initially, it shows an example application, and below we can see the Symfony 2 debug toolbar. It's important to verify that we have our PHP environment ready to code with Symfony 2. So we have a little tool to help us with that, config.php, that will verify it and will give us instructions about how to fix some issues we might have. In my case, it's suggesting me to install APC, but since I'm using PHP 5.5 Opcache, I can ignore the recommendation. Let's take a quick look to a part of the project configuration. In Composer.json, we have the project basic description, version of the needed bundles, that's dependencies, scripts to run after the installation and update, minimum stability, and the location of some directories and the parameters file. When we need to add a new bundle to our application, we have to add it here in JSON format. To know the latest version and its namespace, we can take a look at packages.org. As an example, let's take a look into the Twin Fixtures bundle. After updating Composer.json, we must open appkernel.php to add the new bundle to the array. This normally comes detailed in the bundle instructions. If we look into the config directory, we'll find the parameters YML file, which contains global configuration parameters that the framework was asking for after installing. By default, we'll find the configuration for the database, mailer, language, and the secret token that we must change, since it's used to generate CSRF tokens for forms. In fact, we must modify parameters YML list, since the other one is automatically generated by Composer. This is the way to avoid to pass production parameters into version control systems, such as get. This way, the dist file will contain a safe configuration only for development or for example purposes. The config YML file is the one that's actually read by the framework. So, to get global parameters, they are imported in the file pknn. Next, we'll find all bundle configurations for the project. Symfony 2 differentiates between three environments: development, test, and production. For that reason, each one has a special configuration. For example, this is for development, where we are seeing that general configuration is included and then overridden, so we can add new things. For example, the web profiler, which is the below toolbar that appears when browsing in the development environment. We only want it in the development environment and not in the others, and that's the reason we have it in this file. Let's start cleaning. Let's delete the example Acme bundle that comes when the project is created. Let's start with the source code, src, delete it also from the app kernel, and finally delete the roots as well, which are only specified in development environment. So even if we upload our project to production and we didn't delete these roots, they wouldn't be accessible. Let's create our first bundle named core bundle through a Symfony 2 generator. We check the list, the generator's name is bundle. First, we specify the namespace that must contain the application name. In our case, it will be block, separated by a slash, and we write core bundle. Now we have to write a name for the bundle. The recommendation is to prefix the application name, like the generator is suggesting us, but we are going to enter only the bundle name to make things simple. We accept the default directory. We'll be using annotation configuration in PHP doc format. Now it's asking if we want to generate the complete structure, but we'll say no, since we'll create it when we'll need it. Here we have a summary of what will be generated. We accept. We accept the kernel update, the routine update, and now we have our code generated. The generator has created a little example application in our bundle that greets to the name we enter in the URL. This is to understand the basic way that roots, controller, and view work. Hello world! Let's take a look into the code. From the annotation, we can configure the associated root to the controller action that is going to respond, passing name as a parameter. The controller sends to the view the parameter that comes from the request. And the view displays the greeting with the received parameter. Now that we have seen how it works, we are going to delete the example app because we don't need it anymore. Before writing any code, we are going to work on the model. That's the layer dealing with the database. For that, we'll generate a new bundle, the model bundle. We verify the generators list. The generator is generate bundle again. Let's write block, model bundle to abbreviate. We configure the same as before, annotation. We don't want the whole structure, confirm. And here we don't want routing, because the model does not have to respond to any HTTP request. Here we see that it failed in the routing generation, and it suggests that we paste this in the application main routing file. As this is not what we want, we are not going to do it. We see a new generated bundle. We'll delete the controller directory, and also views because we don't need them. The unity that describes a database table is named entity. Let's generate it. We open the console. The generator's name is doctrine entity. Let's locate our entity into model bundle, and we'll name it post. The configuration format will be annotation, and let's begin to enter our needed fields. First is title, string type, and 150 characters length. We'll also need a body, text type to store the post body, and lastly we'll create created at. Datetime type to save when the post was created. We don't need any more, we'll just press enter. We don't want an empty repository class. I'll explain what's this about later on. And we confirm generation. If we go to the editor, we'll notice a new entity folder, and inside we have our post entity. The generator created the fields and the corresponding setters and getters. First, we'll fix coding standards, which are being marked by the IDE. First thing is trimming trailing white spaces. To do this, we'll take advantage of some feature of PHP Storm or our IDE of choice. In my case, I'll reformat code. And we see that here it's saying that the parameter comment requires a blank new line after it. Let's add it. Next, we'll add validation. For example, let's make title and body mandatory. To do that, we'll include constraints. And we'll write assert as the alias. Now, just below the column, we just write the not blank validation. And we'll do exactly the same for the body. In order to initialize a post date automatically, we'll do it with a constructor. Just using a datetime object. We'll be adding always the PHP doc. Let's generate now a new entity that will store the post's author. We'll locate it into model bundle and we'll name it author. The configuration format will be annotation. Let's add a name, string type, and 100 characters length, and also a created at field. Datetime type. As we see, a new entity is created inside the entity directory. And everything is generated, so let's fix coding standards. Trim trailing white spaces, add a blank new line after parameters, and now the IDE marks it as valid. Let's also add validation for the name. Just below the ORM column. And from now on, it will always be checking that this field is not empty. We'll add also a constructor with its related PHP doc. Right now, our entities have duplicated code, because both have the same created add field, the same constructor, and the same setter and getter. So we'll create an abstract class from which these entities will inherit this behavior. We'll create this new class into entity and we'll name it timestampable. We'll open the PHP tag and we create the namespace. That will be block, model bundle, entity. Let's write a little description. And next, we'll be cutting and pasting what we have in Author. We'll get also a constructor and the setter and getter. We'll also copy the ORM. And next, we'll extend from timestampable. We'll do exactly the same in post. And we'll delete from post everything we are inheriting from timestampable. At this moment, we have just refactored our entities because we have removed code duplication. Doctrine doesn't know this is an abstract class yet, which entities must inherit from. So we have to tell it about explicitly. Now Doctrine knows, and we can close this class. Now we'll be making the relationship between author and post. An author can have n posts, and a post can have up to one author, at least in our example. In our author class, we'll generate a posts property. And in the PHP doc, we'll create an array collection. And in the Doctrine directive, we'll make a one-to-many, because as we said, an author can have n posts. With target entity, we tell where it points to. Here we make the inverse relationship, mapped by author. And we'll add a cascade option. The cascade option means that when an entity is deleted, I mean when a record is deleted, its related registries in the other table will be deleted as well. For post, we'll do exactly the same. Below, we'll add a private field that will be author. And as a comment, we'll add the properties. It will be an author, here it will be just the contrary, many to one. The entity it points to is an author. And the inverse relationship is posts. Have in mind that in many to one it's not mapped by, but inversed by. We can also control how this will be saved into the database. We can do it with join column. We write a name, author ID. We'll also add the referenced column name, the ID, and as default relationships can be null, we are going to avoid it. And finally, we'll add also a not blank validation. We don't need to generate the methods manually for our newly created fields, as Symfony 2 offers us a generator for that. In this case, it's Doctrine entities. We have to pass it the bundle where we have just created it, and pass it the entity name. It has just created all missing methods, and as we see here, it has created a new backup file ended in tilde. Let's do the same for the author. If we take a look into the code, here it is. It has generated methods for the author. Let's fix code and standards. For this case, it's not necessary the full namespace. And we have it ready. In the author case, it has also generated a constructor, which will be moving above. Let's fix code and standards. It's time to work on the database. The first thing is to start the web server. And now, with a Symfony 2 generator, we are going to generate the database. We'll use database create. I'll check it with an editor. Right, here it is, Symfony 2 block. All changes in databases are recommendable to be made in a migration, as it offers us an exhaustive control and the possibility to make a rollback. That's undoing changes in a controlled way. To do it, we need the bundle that gives us this feature. That's Doctrine Migrations bundle. We'll add it to Composer, just below Doctrine bundle, and we'll try to update. Composer update. It raises an error. This error says that we need to define Doctrine Migrations. Just above, we'll add Doctrine Migrations. And we are going to update again. It starts to install dependencies, and finally it installs migrations and the migrations bundle. Next step is adding our new bundle to the Symfony kernel. We'll add it just below Doctrine bundle. Let's create our first migration. This migration will contain the author and post tables creation, which correspond with our entities. We are going to use, of course, a Symfony generator. In this case, it will be Doctrine Migrations diff. That will look for the differences between our code and the database. We have an error. This error says that we have to update our time zone, because the command we have just typed uses dates somehow. In the case of migrations, it adds a date in the file name for a more visual control. To know where do we have PHP ini, because it varies between systems and package managers, we can use the command php-i. We add a pipe and then grep php.ini to filter by the file we are searching for. php-i shows information about the PHP runtime interpreter. It says that I have the configuration in etc, which I suspect it's the system default PHP. As I don't want to use it because it's an older version than the one installed by Homebrew, what I'll do is to modify my bash profile in order to read first the Homebrew executables. To do it, I open a new tab, I go to my home directory, and I'll open bash profile. Here, I'll add an export path that reads first USR local bin, and then path. I'll load Bash profile, and now I'll check that it reads the PHP version I installed. I close the tab, and now I repeat the same command as before to see where is the new php.ini. But since every terminal tab has its own environment, this one is not getting yet the PHP version that I need. Then what I need to do here is the same source command that I did before. And now it's giving the correct route where I can find the php.ini that I'm going to edit. Now I'm searching for the time zone. And here we have it. It's initialized to the capital of the country where I reside. That's Spain. So I suspect that it was using the system PHP installation. So it's not necessary to make any change. So I'm going to repeat the migration diff. And yes, now it has generated a new class containing my migration with the current date. If we take a look into the source code, we'll see a new folder named Doctrine Migrations. If we enter, we'll see our new migration. As we see in the comment, it's an auto-generated migration which we can modify to our needs. This means that we can create new fields, tables, indexes, and what we need. Even in the case of a complex migration, like for example, a data transformation from an existing database, we can perfectly use a migration to generate all required steps to replicate it to production. But getting to the point, here we see two methods created by the migration, up and down. Up is for when the migration is run, that is what we are going to do next. What it does is to create our two tables and their relationship. And down is for when we do a rollback. That's when we want to revert changes. What we do is the opposite effect, delete the relationship and both tables. This is automatic and saves us time. So we'll run the up method, that's running the migration. Running a migration is very easy. We get the previous command and we replace diff with migrate. It asks for confirmation, we say yes. And here we can see how it created the tables and the relationship. If we check it, I can see that it created author and post. It also creates an extra table with migration versions. If we go to content, here we can find the latest migration. Versions are not replaced here, but added. So we can see all run stacked migrations, so we can revert to any version through this table. At this moment, I'm introducing a new concept that will save us time in our daily work. Fixtures. What fixtures do is to create data when we delete the database, so we don't need to do it manually. We'll install a new bundle, Doctrine Fixtures. Open Composer, and below Doctrine Bundle we add Doctrine Fixtures Bundle. Next, I'll do a Composer update. It installs all dependencies and finally the Fixtures Bundle. Now we go to the Symfony kernel and add this line. Now we are going to create a fixtures file for every entity. In Model Bundle, I'll create a new directory named Data Fixtures /ORM. This has to be this way, it's a convention, else fixtures will not work. Inside ORM, I can start to generate my fixtures. I'll assign a number to the file. That will be the order in which it will be run. And next, a descriptive name to tell that these fixtures will create authors. I begin writing the namespace, block, Model Bundle, Data Fixtures, ORM. This class is extending from abstract fixture. And we see the IDE is adding the use statement and implements order fixture interface to control the order. First is a method named getOrder that just returns the order number. Notice that the fixture system doesn't pay attention in the number I prefixed to the file, but it will call to this function. Before going on, I'll add some comments. And here, as getOrder comes from one of the classes I'm extending, I'm going to inherit the comment. Next, I'll write the load method that gets an object manager. That will be the method that will be actually called to load these fixtures. Here the code is completely free. I'll create a new author, and I'll name it David. I'll create another author and I'll name it Eddie. And finally a new author with name Elsa. Then I'll call the object manager and I'll persist the objects. Now Doctrine knows these objects have to be saved, but it is not going to do it yet. To force it to do it, we have to call flush. Let's write the same comment in load and save it. To generate fixtures for posts, I need to write a post. But to avoid to write a real post, I recommend to use the ipsum.com website that will generate random lorem ipsum text that we can use for our fixtures. So back to the code, I generate a new fixture, this time with order 15, and I'll name it posts. I write a namespace, a little description, and next I define the order. Here I'm going to paste the same inherit doc. And the same for the load function. That will be receiving also an object manager. So let's create the first post. I'll be assigning an author to this new post that will get something returned by a future new method named getAuthor. This author method will be private, getting an object manager and a name. That's what we are sending. Let's define first what is this about. Get an author. It will have two parameters, an object manager and a string type name. This will return an author object. Here, we are seeing the first call to the database through Doctrine. I just get the author repository, and I'm going to search for a registry from a name. That name is what the method is receiving. Finished. Now I'm generating a second post. This post is by Eddie. And finally a third post. This third post is also written by Eddie. I called to the manager and I processed all 3 posts. Lastly, I call flush. Okay, now we can run our fixture. To do so, we are checking the commands list, and it's Doctrine Fixtures Load. Let's go. We accept, and we have an error. We see that the error is raising when authors are loading, and it's saying that created add cannot be null. This is because we added a validation. This validation is not being called for some reason, so let's check the author code. Open the entity directory, author entity, go down, and yes, we see that the constructor is being overridden. We have to call the parent's constructor, which is the one inheriting by this entity. Let's check that here is where the created add is being initialized. So let's call the parent's constructor. We have now fixed the issue, so let's try it again. And here we have a new error. It seems not to be finding post in our post fixers. Let's check line 28 for the problem. It's a little complicated to go fast to that line if we don't have enabled that feature in our editor. So the first thing we're gonna do is to enable it. We go to Preferences, write in here line number, and here it is, in Editor Appearance. Accept, and now it's much simpler. We go to line 28 and effectively we see that the class is not being recognized. So that means it's not in the use statement. To add it, we do a control space. We choose the correct one and we see that the IDE is adding the statement automatically for us. We repeat the command, we confirm, and now we have the data in the database. Let's check it out. I open my editor, I reload, and here I have authors with their creation date, and I also have posts. Let's build a post list page. As we already have information in the database, let's display it. First thing to do is to create the controller. To do so, Symfony 2 offers us a generator. In this case, it's generate controller. The controller name will be post, and we'll place it inside core bundle. Routing format will be per annotation, so we accept the default value. We accept tweak template format, and now the generator offers us to generate the first action with need. In our case, it will be index. All actions have to be ended in action. The default suggested route is the action name, but as it will be the blog main page, we just write a slash. We accept the template default file name, and by now we don't want to create anything else. So we press return, we confirm generation, and we have our controller created. Let's take a look into the code. Let's close this. We enter in core bundle, and inside controller we have two. The one we have just created, post controller, and the one generated by the application by default. We don't want this one, so I'll delete it. We open post controller, and we see here the code generated by Symfony 2. First thing is fix coding standards. And to get this working, it has to return something. Action has to always return something to the template. In this case, we'll just return an empty array. We'll add a description here and the return of the array. How can we test what we have done until now with a test? The generator automatically created a test directory inside core bundle, and it also created another one inside model bundle. But we'll not need this one, so we'll delete it. Let's open tests. Here we see the default one that we are not gonna need, we delete it, and we open the one for the post controller. First thing is fix coding standards. So we are going to generate comments. And here it will check that the call is valid. So we'll make an assert. The assert is who checks what is returned. This uses PHP unit, so we'll make an assert too. That's going to check that the returned value is true. We get the client's response and we verify if it's successful. Next, we add an error message for when this is not successful. This is made to ease error debugging. Back to the terminal. How can we run tests? Using PHP unit -c app. That is where the PHP unit configuration is stored in a Symfony 2 project. In this moment, I don't have it installed, so I'll install it using Homebrew. It's as easy as typing brew install PHP unit. Okay, we have it. And we have also a beer. Woohoo! Now we repeat the previous command, it runs the tests, and if everything is correct, the below bar will be green. That indicates the number of run tests, and below we can see the number of assertions. So in a test, we can have n assertions. In our case, we have one test and one assertion. Everything's fine, so the index page is working successfully. When loading localhost at port 8000, where the PHP web server is running, we'll see this welcome message. Just below we have the Symfony debug toolbar that shows the current Symfony version, the PHP version, the current environment, the current controller and its root name, total time that was needed to process the request, memory usage, whether we are authenticated or not, and the number of database queries together with query time. We can also click on any item to get more information. Now it's time to improve the looks, so we'll be working in formatting templates. We'll close these tabs. We'll open the app directory, resources, views, and here we have a file named base. This file has the main application skeleton in HTML format. What we'll do is to delete the default welcome message, leaving it empty inside the title block. The title block, in the case of Twig, can be initialized when we inherit from this template. We'll see it later on. We'll leave it empty by now. Next, we'll add a pipe and we'll write Symfony 2 block. We'll leave everything else as it is. Once we have the skeleton created, we'll generate a layout for the core bundle. We'll close the main skeleton. We'll go to core bundle, resources, views. We'll delete default. And here we'll create a new template named layout HTML Twig. The first thing this template will do is to extend from the one defining the main skeleton. That's done this way, writing its name and prefixing these symbols. Here we have to write the bundle name, and here the controller name. But since it's the main skeleton, they have to be empty. Next, we'll fill up the style sheets block. If we remember, style sheets are defined here, as well as the body and JavaScript block. So, style sheets, we close the block. And here we'll write a link of type text CSS, pointing to an asset. Assets is the way Symfony 2 has to deal with images, CSS, and JavaScript files, among others. In our case, it will be in bundles, core, CSS, main.css. But where comes this directory from? It comes from the web directory. It's the public directory. We have it right here. There are some rests from the example application that can be deleted with no problem. Let's go on. We'll define the body block from the main skeleton. We'll put an HTML5 header. We'll write Symfony 2 block as the title. And a nav to define navigation. It'll have only one item, with an empty link by now. And here we'll write home to go to the blog's main page. This is a literal. Symfony 2 offers us internationalization. That's a file whereby we can define translations. It's recommendable to write literals with internationalization in mind, because we'll save time later on when translating to other languages. So instead of writing home, we'll open Twig tags to show a field. We'll use Twig tags to display something, we'll write home, and we'll pass a Twig filter named trans. That will check the home translation and display it as a literal. Let's go on. We define here a new block which is not in the main skeleton, and it's named sidebar. I mean, sidebar will reside in the core bundle layout. By now it's empty. Here we define a main section, and we define the core bundle output block. I mean, the main output. Lastly, we place the footer. We write the copyright symbol, Symfony 2 block, and before we'll display the current year. How can we do it? With Twig. We just call dateYear to display the year. And we send it now to display the current year. Let's create now the translations file. Where must it be located? In resources. It's a new directory named translations. Inside translations, we'll create as many files as translations we want. In our case, we'll create only two, one for English and another for Spanish. It has to be named messages, the language name, and ending in YML. Here we write the keyword that we defined before, home, and we give it the literal. Let's do exactly the same for the Spanish version. Next, we'll create the core bundle CSS file. Public files will be in a folder named public. And inside public, we'll generate another directory for CSS. And inside here, we'll place the actual file. Let's begin with HTML, position relative. Min height 100%. Why am I doing this? Because we'll use a sticky footer. and that's a footer that will stay at the bottom of the page, even if we move. We define a body with margin 0, 0, 80. We'll define the header style, we'll assign it a background color, we'll assign C3, C3, C3. That's gray. And a padding of 10 pixels. The inner paragraph will have a size of 28 pixels and a margin of 5 pixels. Header items, that's an unordered list, will have a margin top of 20 pixels and a padding of 5 pixels. Its elements will have a display inline to display them horizontally. The list style will be disabled. Between them there will be a separation of 20 pixels. And each one will have a padding of 5. And we'll also assign them a background color. As we see here, it's a little darker. Section will have a margin of 10 pixels and a width of 65%. The link for header items will be white. The footer will be position absolute. Left 0, bottom 0, let's define a height, a width of 100% of the page, a top border of 1 pixel solid and color, light gray, and a padding of 10 pixels. We'll also assign it a font size of 13 pixels. Finally, let's define a style for links. We'll define a color, blue, and we'll remove its decoration, the underline. We'll also style hover and active with exactly the same color. And we'll also remove their decoration. Or maybe not, we'll leave it as underline. This way we'll improve usability. If we go to Web Bundles, we don't see core here, which is pointed by our layout. Here can we see it. Instead of creating a link manually through a symbolic link, for example, under a Unix system, Symfony also offers us a generator to ease the process. If we check the list, we look at the beginning and here we find assets install. That does exactly that. But we'll pass the symlink option for a symbolic link to avoid duplication in our assets. Now, if we look at the code, we'll see that it created core that is pointed, as we see in the icon, to our main CSS. Lastly, we have to modify the view of our index action. To do so, we go to Resources, Views, Post, Index. And this is what the generator created for us. Let's customize it. In Extents, we write Core Bundle, Layout, to use our new layout. In Title, we'll write Post, Plural Trans. Instead of body, we defined section, and our template is now customized. Let's check it out. And here we have the new layout with our CSS loaded. We can see some details, like for example the title, that is not yet translated, and home, which is the keyword. But it's not the literal we want, so let's fix it. First we add posts plural, Let's do it this way in order to add more entries in post. And exactly the same for the Spanish version. As we have seen, it's not displaying home with a capital H nor inicio. That's because it's not loading the internationalization system. To enable it, we have to go to app-config, config YML, and this commented line has to be uncommented. So the translator takes the default language that we configured in parameters YML. And that's English. Back to the browser, we reload, and we see that it took English as the default language. Posts and home. If we take a look into the post fixtures file, in model bundle, data fixtures, posts, we'll remember that we created 3 posts. So if we want to display them, we have to adapt the test file and we'll wait for 3 posts. We go to the controller test and we'll add a new assert. In this case, we'll count 3 H2 HTML tags. We'll add a message saying that there should be 3 displayed posts. And that's it. What we have right now is the client creation. This client requests, through the get method, the application index. And this returns a crawler. We'll use the crawler to filter things, so we can examine the response of what we request. For example, it's what we are using in this new assert. We are filtering by H2 tags using the crawler. And of course it fails. This is one of the principles of TDD development. We start writing a failing test, so the result is red, and once it fails, we develop it. Later, when functionality is implemented, we run again the same test, and it should work, displaying itself as green. So let's start developing now. We open the post controller, we are going to store posts in a variable, and we'll call getDoctrine. That's a default call available in any controller extending from the controller class. We'll call the repository of model bundle post, which we can use to search by identifier or other fields. And we'll search for all available posts. Now what we'll return to the view is, in a variable called posts, we'll pass this result. Okay, in the view, we'll delete this string generated by the generator, and we'll deal with the array coming from the controller. To do so, we'll use a for loop, this way. We close the block, and now for every post we'll include what is known by a partial. This partial is stored in core bundle, post, and I like to differentiate partials from normal views with an underscore. I'll call it underscore post, HTML, twig. And I'll pass the current post to this partial. How can we pass parameters? With this twig array notation. I'll tell it that post is post. The first one is the variable sent to the partial, and the second one is the variable of the current loop where I am. I'll create then this partial. Underscore post HTML twig. This partial will contain an HTML part that will be wrapped in an article tag, which will have a header. And here we'll write a title and the post date. Next, in a paragraph tag, we'll put the post summary. In header, we'll first put the title with an H2, and inside this H2, we'll put a link that will link to the final post page. By now, we'll leave the link empty, and we'll write the post title. This is the way Twig has to access the object methods. If we remember, the post entity has a method called getTitle, generated by the Symfony entities generator. To call this method, we should have written getTitle, And in fact, it would work. But to make development easier, we can just write this. And Twig will manage to add the good part internally. Let's annex a paragraph here, where we'll put a small text with the date and author. I'm going to start with a date, and for this I'll put the post on identifier. That's a translation that will display the literal posted on. And next, I'll put the date. We'll do this with the HTML5 time tag. In the datetime attribute, we'll pass a time special format and we'll display our entities created at. And we'll format it with the date Twig filter. The special format that we'll put here will be also using post created at with date filter but with the C option. That option is the same received by PHP. Looking at the datetime functions documentation, we'll see all parameters we can pass on. At the end, we'll see that C is the ISO 8601 standard, with a date looking like this, which is the one used by HTML5. Back to the code, let's go on. Now we'll put the by, that's the author, and we'll annex an empty link by now. That will be the author name. How can we output the author name if we only have the post? Using the relationship. Instead of writing getAuthor, I can just write author, and now that I have the actual object, I can access the name. Now we're going to get the post summary. We write post body, and we pass the truncate filter. We'll get 400 characters. Next, we'll put an HTML dash, which is a little larger than the normal one, with this HTML code, H212. And next, another empty link that will point to the post. We'll put a literal read more, and next a double right arrow with an HTML code as well. We'll add these translation identifiers, we open messages n, and here in post we add on. Above we add the by and the read more. We'll do the same thing in the Spanish version. And the on. If we try to run the test again, we see that it's failing yet. This is probably because of an uncontrolled error. So let's clear up any doubt and let's check it out in the browser. Reload. The error is that the filter truncate does not exist. This filter belongs to Twig extensions and we haven't enabled them. They come installed by default, but they are disabled, so we have to enable them. We have to go to the General Application Configuration, and just above Twig, let's add something. That's Services. We're not gonna explain services in detail now, but we can advance that it's about dependency injection. Later on, we'll see it more in detail. By now, we'll write Twig extension text. Class name is Twig extensions extension text. We'll pass tags, in particular the name Twig extension. If we try to run the test again, we see that it works properly, so we can go to the browser and see how it looks like. Reload, and here we have it. It seems that font size is too large. Let's try to fix this. Let's add some style to post's body. To do so, we access the CSS, and below section we add article header. It will have a background color, transparent to avoid that gray we saw before. Padding left will be 0. Title, that will be shown only in the post page by now, will have a size of 32 pixels. And we'll leave a margin bottom of 5 pixels. But for the H2 that appears in our list, we'll put a smaller font size, 24 pixels, and a margin bottom of 5 pixels too. For the link, we'll put a color close to black. And for the date, we'll put a smaller size, 14 pixels, and we'll disable the margin. Sometimes Symfony doesn't recognize changes in the assets. In those cases, we have to install assets again. This will fix the issue. Back to the browser, reload, and we see that it's better now. At this moment we have few posts, but what would happen if we have 100, 200, 1000 posts? It would be interesting to have visible a list of the latest. I think the right zone is a good place for it. How can we do it? Let's work first in the model. What we need is a custom query that gets the latest posts from our database. Queries should be written in a repository. Each entity can have its own repository. So we're going to work in the posts repository. We access to the model bundle, post entity. How can we set a repository for this entity? In entity, we add a parenthesis and we write the repository class equals to the namespace, block, model bundle, repository, which will be created now. Post repository. That's it for the entity. We close this and create that new repository directory. Inside here, we'll create a new file, which as you saw, it's named post repository PHP. Let's open the PHP tag, write a namespace, block, model bundle, repository. We write our class, post repository, and this will extend from entity, repository. We open brackets and type the function we're going to write. Find latest, for example. We are passing the post number that we need to this. Let's describe this method. Find latest. This is an integer. How many posts to get? About the class, we are gonna leave it by default. Okay, here is where we are going to write the custom query. To do so, we'll use a Doctrine 2 feature called Query Builder. So I think it's very useful to write a private function that builds that query. So we type private function get query builder, and here we'll get first the entity manager, which is the object used to communicate with Doctrine. Since we are inheriting from entity repository, we already have this method. We'll put our query builder into this variable, and we'll generate it with get repository. And since we are in post, we do model bundle post. And we call to create query builder. We assign an alias to this. I always use the abbreviation of the current entity. In this case is post, so it will be a P. And lastly, we return it. What can we do with this? In our find latest function, we instantiate query builder again, and we get it with our private function. Now that we have the query builder, we can write our query, as we want all we don't need select nor where, but we can order. We'll order by created at. That's the date, and we're gonna do it descendant. And we'll limit with the past num variable. And that's it. Now we just have to return the results this way. We see that the IDE is complaining, and that's because it cannot find the return tag. Let's add it. Now we can go to the controller and get the latest posts. Get doctrine, get repository, model bundle post, and find latest 5. We'll pass this to the template. We go to Views, Post, Index. And we'll add the sidebar block, which is ready in our layout. We'll put the aside HTML5 tag, ideal for these cases. We'll put as the title post latest, and we'll put a loop from the latest posts variable. We'll display a paragraph for each one, and an empty link that will just have the post title. Let's check it out. Reload, and we see that it loads correctly. It's displaying our 3 posts. We have asked for 5, but since we only have 3, it displays 3. Now we have to style it, but we'll translate first this literal. We open the translations file for English and Spanish. We'll put here latest. And the same for Spanish. I noticed that I wrote an S here that was a typo. Reload. And we have latest post translated. Let's style this column. Here, for example, we can write aside with a right float, a width of 30%, a padding of 5 pixels top and down, and 15 pixels for both sides, margin of 5 pixels, background color of some kind of light gray, and a darker border. For its title, a bold font weight. That's it for now. If we reload now, we'll see the change that feels much better. The next step is opening the post. To do so, each time we think about writing a new controller action, we have to think about the root first. In the case of a block, I think that for a post, it's better to load the Slack in the root. To do so, we'll use a doctrine library named Doctrine Extensions, which between other behaviors offers us the slackable one. But there's a bundle for that. We'll use the Stuff Doctrine Extensions bundle, which has the following documentation with using and installing instructions. We'll open composer.json, and just below migrations we'll add a new bundle. Next we go to the kernel. And below Doctrine we'll add the bundle. As you see, it appears in red. That means that it cannot find the namespace because we haven't run Composer yet. we call Composer Update. We see that it installs Doctrine extensions first, and then the stuff bundle. Next, we go to the configuration. And at the very bottom, we'll add Doctrine extensions configuration. It's a good practice to mark where starts each bundle configuration. We'll write ORM, default, and we'll enable here the slackable behavior. We can now add a Slack to the post entity. First, we'll add a new use from the namespace Jetmo, mapping, annotation with the alias Jetmo. Just below title, we'll create the Slack property, which is a string type. We'll enable the slackable based on title, and it will not check for uniqueness. About Doctrine, we'll specify the maximum string length. Next, we'll generate the setters and getters. It generate Doctrine entities. We pass model bundle post. It generates a backup and updates the post. Let's check it out. If we go to the very bottom, we can see the new getter and setter. We'll add a blank line here. And we'll move them below the title, getter and setter. We'll replicate this to the database with a migration. App, console, Doctrine, migrations, diff. This generates a new migration, so we'll run it. To avoid the confirmation each time, we can pass the end parameter. If we check out the database table and we reload, we can see the new Slack column, but it's null. To fill it up, we'll run the fixtures again. Doctrine, fixtures, load -n. We check it out again, and now we have the Slack perfectly generated. Since the Doctrine extensions bundle offers a timestampable behavior, we'll use it. So we'll refactor the behavior that we developed through the constructor. So we go to the configuration, config YML, and we'll add timestampable true. Next, we go to our timestampable class, and we delete the constructor, because this behavior already comes in Doctrine extensions. We add the use statement. And in created add, we'll add Jetmo timestampable. And we'll set it up for the create. Since timestampable does not have a constructor, we go to author and we'll delete the parent construct to avoid errors. To check that it works as before, we'll run the fixtures again and check in the database that everything is in its place. One of the advantages of refactoring this behavior in a new class is that all changes are inherited by the entities. Let's check it out adding an updated. We'll change this. Update. Updated add. And here we'll allow no label. Why? Because when a new post or author is created, it's not actually updated. Let's copy this, and we'll use it for the updated. This should be timestampable. and these two. Okay, we create a migration and run it. Let's check it out in the database. Here we see the created ad and the updated ad. The same for post. We are now ready to develop the post show. That's the post itself. We'll start thinking about a test for it. We'll need to load the first post from the database, and for that we'll need a custom query. So we'll go to the post repository and we'll write a new method. Its name will be findFirst. Let's comment it. Find the first post. This will return a post object. And we'll write it this way. We'll order by ID, ascendant, and we only want one result. When we'll be returning it, we call getSingleResult, which returns only one result. Let's write the test. We go to Core Bundle, Tests, Post Controller Test. Here we add test show. We'll get the client like before. Create client. Now we'll get the first post. This is the way to call the database. First we call the service container, which we'll look later on, and then calling the Doctrine service. Once we get Doctrine, we go to the manager and then to the post repository. And there we call findFirst. For the IDE to know what kind of object is this, we can tell it's a post type. Now we initialize the crawler, client, request, get, and we pass the Slack prefixing the slash. This will be the route to load the post. The assert will be the same as before, assert true, client, get response, and we verify that it's successful. Also, we'll use a new assert, assert equals, and we'll compare the post title to the h1 tag that the crawler finds. This will be translated to text. The error will be invalid post title. This is what we want to develop. We'll try to run the test. And obviously we see that it doesn't work. So let's develop it. We open the post controller and add a new action. Show action, and they will pass us a Slack. Let's configure the root. First we'll say it's a string type. Let's comment it, show post. The root will be stored in slash, and pass a Slack. This is the way Symfony 2 gets the root parameters. Let's implement it. We'll get the post from the post repository. And we'll get a registry from the Slack that we are receiving. This way we have the post. Now we'll check that the post is correct, because it's possible that the Slack is invalid, or maybe the post is deleted and the visit comes from Google. So we check that the post is null. And in that case we have to throw an exception. Exceptions are thrown calling to create not found exception. And here we can put an optional message. Post was not found. We see that the IDE tells us to declare it here. So we'll put throws not found HTTP exception. And also we'll return an array. Let's return the post. Next is the template. We go to Resources, Views, and inside Posts we generate a template. The first thing is to extend from core bundle. Layout, because it's the layout of our core bundle. Then we assign a title. That will be the post title. Let's use a sidebar. With an aside. This time we'll do it differently. We'll put the post author. This will be an empty link by now, with a title post by author, for example. And here we'll use a parameter. We'll use a translated literal that will get a parameter. That parameter is the author name. How do we pass it? In Twig array format. We pass it between percentage symbols. We'll call it name, and we'll initialize it to post, author, name. Inside the link, we'll put the same, the author name. Now for the section. We'll write an article here, and we'll style it with a post class to differentiate it from the index style. We'll put a header and an h1 to make it compatible with search engines. Here we'll write the post title. Here we'll use post on, which we created before. The same for the time. Created at, same as before, with ISO format. And here we'll put the default date, which will be got by Twig using the selected language. Just below, we'll put in paragraph form the post body, with a concatenated filter, name it new line to BR. That all new posts lines will be converted to the BR HTML tag. Let's run the test again. And now it does work. Before we can test it, we must update the links, else we cannot get access to the post. We could access manually, but let's update the links better. Let's close all this, we go to post, and here we have a link. Links in Twig go with a call to path, and here we must type the road name. Symfony 2 uses the bundle name, in our case core bundle, preceded with the application name, block in our case. Next the controller name, that will be post, and then the action, that will be show. This is the default behavior and can be changed in the root definition. But if we cannot remember it, we can always look it up through the console. We just have to type router to back. And these are all our application routes. In particular, we are interested in this one. So we passed it here. And if we come back, we see that it requires a parameter, which is the Slack. So let's pass it from the path. Slack. And here we have it. Let's do the same here. And this is already updated. Let's go for the index. We'll add it here. And that's it. We can try it now. Reload. We can now click on it. In the bottom bar, we can see the Slack loaded. Click on it. And we have our show action working properly. One missing detail that we are gonna change is the author literal. We open translations. And for Spanish. Reload. And it's ready. To write this test, I'm going to need the first author from the database. To get the first author, I'll write a custom query. And to do so, I need an author repository. So let's create it. I go to repository and I create a new file. We are in repository. I start my class. And I extend from entity repository. I'll create first the function that will give me the query builder, as we did before with the post. We initialize the entity manager. And here the query builder typing model bundle. Author, and the creation call. We'll assign an A alias because we are in author. And I return it. Next, I'll write the function that gives me the first author. I get the query builder. I order by identifier ascendant, and I limit by one result. Next, I'm returning a single result. Let's write the PHP doc. And I'll return an author. Next, we'll add the Slackable behavior to the author, because when we access to its posts list, we'll place its Slack in the URL, so we'll close the repository. We go to author, we'll add a new use statement, we'll set here the repository class we have just created, From now on, Doctrine knows about it. And here we add a Slack. Let's configure it. It's a string type. It's based on the name field. We disable the unique. And here we set a maximum string length. That's 255. Let's generate the setter and getter. We type model bundle, author. Back to the code. We see that at the very bottom it has generated them. We fix the coding standards. And we'll place it just below the name. We go to the terminal to create a migration. We run it. And we check it out in the database. We go to author, and here we have the Slack field. What problem do we have? It's still not generated. So let's run Vectors again. Reload again, and here we have it. We have everything we need to write the test. After initializing the client, let's get the first author. We get access to Doctrine. We get the manager and the author repository. Here we call our new method findFirst. Also, we'll count how many posts has this author. Next, we'll define what type of object is author. And through the client, we'll get the root. Instead of show, we'll type here author, a slash, and next we'll put a Slack. To do that, we'll concatenate our new author object, and we'll get the Slack. And we're ready to write the assert. The first assert will be an assert true. And we'll check that the response is successful. That the controller is responding successfully. I get the response is successful and the error message. The next assert will count how many posts has this author. We get the actual posts count, and through the crawler we filter by the h2 tag. Next, we write the error message. There should be the posts count post. We have just created our test. Let's run it. We load PHP unit. And obviously there's an error because it's not developed yet. Close the test. And in the author controller, the first thing we'll do is to set the root that the test is waiting for. It's author and the Slack. For the implementation, we'll get the author. We get Doctrine, the author repository. We'll get one author from the Slack that we got. Sorry. Here we have the author. We see the IDE showing up an error, and that's because the Slack is not defined. We have to type it here as well. We now see a PHP doc error. It's saying that the Slack is undefined. So let's add it here and we'll add a description too. Show posts by author. And finally we set here a parameter string Slack. To check if the author is valid, we'll do the same that we did with the post. If author is null, we'll throw a not found exception this way. PHPDoc complains again. In fact, who is complaining is the code sniffer, which is integrated into the IDE. It's saying that the throw is not defined here, so let's add it. Once we have the author, let's get all its posts. We get doctrine, the post repository, and find all by this author. The only remaining thing is to send them to the template. Let's pass first the author, and then the posts. To finish, we'll add the new return here. It's an array. That's all for the controller action. Now let's write the template. We open show. The first thing will be to extend from the correct layout. That in our case it's a core bundle. And then layout. In title, let's add a new identifier called post by author. Here we'll pass a parameter. It will be the name. Next, we'll define the sidebar. Aside. And we'll type post by with no author. This hasn't any parameter. The only thing we'll display here is the author name. Here, we'll change body for section, delete the default code, and let's iterate over the posts. We'll include here the partial that we have already implemented. This way, we reuse code. It's in core bundle, post, underscore, post, HTML, tweak. And this partial requires the post object. Back to PHP unit, run it, now it's implemented. Let's set up the routes pointing to this new controller. Open the post partial and post show. Let's type the path tweak method. It requires a route. Let's check it out using the router debug. We have it here. Block core author show. Copy it and come back to the editor. We paste it here with a Slack parameter, which can be gotten from post author. That's all for this template. Let's copy it. And we'll paste it here. That's all. Let's check it out in the browser. If we go to the main page and we click on some author, we see the only post written by David. Clicking on Eddie, since he has 2 posts, we see that it's filtering well. What will happen if we check for another author we have? That's Elsa. Okay, let's replace Eddie with Elsa. We have a blank page, so it will be interesting to control this case as well. We open Author Show, and the Trick 4 supports an else, where we can control that case. Let's display a paragraph and type author empty posts. Before checking the result, let's translate it. Go to Translations and open the English version. In Post, below On, we type by, posts by. We also add by author. Here we are getting the name parameter. And at the bottom we type author for when there are no posts. For example, we can type this author did not write any post yet. Let's do the same for the Spanish version. By posts por, by author, posts por name. And in author, empty posts, este autor no ha escrito ningún post todavía. We close the translation files and let's check it out. We are in Elsa case. Reload. And we see that this case is now controlled. And we have translated also this literal. Let's take the opportunity to add a link to the main page. If we check the router at the back, we see that the main page that points to the slash is named blog core post index. So let's copy it. Back to the IDE, we go to the layout, and where we have home, we type path, and the root we have just copied. Let's check it out. Reload again, and now we see that it redirects successfully to the root. What could have become of blogs without comments? Let's generate the comment entity. It will be in model bundle and we'll name it comment. Annotation, and let's add the first field, author name, string type, length 100. Next will be body, type text, and that's it for now. We don't want an empty repository class, and we do confirm generation. Here we have our new entity. The first thing we'll do is to extend from timestamp table. We'll add a new use statement, Symfony, component, validator, constraints as assert. And we'll set a not blank validation to the author name and to the body. Next, we'll create the relationship between the comment and a post. We add post, we open a PHP doc, it will be post type, and the relationship will be a many-to-one. Target entity will be post, inversed by comments, which we'll create next in the post entity. The join column will be the post ID, and the referenced column name ID. As always, no label false. And we'll add also an assert not blank. Now let's generate the methods for this new post field. We get the previous comment, we type entities, and it will be model bundle, comment. Back to the code, we go to the very bottom, and the methods are now created. Let's clean the code and fix the coding standards. This is not needed because it's in the same directory. And that's it for the comment entity. Next, we'll add the relationship with comment in the post entity. Below author, we'll put comments. We open a PHP doc. This will be an array collection and a one-to-many. Target entity will be comment. Mat by post. Cascade remove. We'll generate entities again. In this case, it will be for post. We go back to the code, and here we have the add comment. Remove comment and get comments, as well as the constructor that initializes this array collection. Anytime we have an array collection in an entity, we have to initialize it with a constructor. I'll move this constructor above, but first I'll clean the generated code. I'll place it above the getID. Array collection is added by the IDE, so it's not needed to set the complete namespace. And that's all in this entity. Okay, let's transfer all this to the database. We create a new migration. We run it. And let's check it out in the database. Update. And here we have our new comment table, but since it's empty, let's fill it up with fixtures. We open data fixtures, and inside ORM we generate a new file. Now it's time for 20 comments PHP. In this file we'll create 3 comments. We open the class, comments, and we extend from abstract fixture. We implement order fixture interface. We create the PHP doc with something more descriptive. Next, we implement getOrder. That will be 20. Here we'll inherit doc. Let's go now for the load method. Object manager, manager. First, we'll get all posts. And we'll generate comments. The first one, the second, and here we go for the third. I'll inherit doc here also. Next, I'll create a counter variable. And I begin a for each. I create a new comment. It should be from entity. The author name will be someone. The body will be from the comments array, our counter variable, and we'll increment it here. And the post will be the current post inside this loop. To finish, we'll call persist for the new comment. And then at the end, when we are outside the loop, we call flush. This way we will not be querying the database on each loop iteration, but will make all queries together at the end. Now I load the fetchters. I'm going to check the database. And here are all the comments. And of course, all previous information is kept. One thing to notice is that each time we load fixtures, the database will increase the identifiers. It's for that the identifiers are not starting from 1, but they are starting from 1 in comment because this is the first time I load comments. In case we want to reset this, we can do it manually in SQL resetting this counter. Or else we can append the purge option when loading fixtures. Now it's time to show these comments. Let's start writing a test. In the show test, we add a third assert that checks for a greater than or equal to 1. And we'll filter by article comment and we'll count them. The error message will be there should be at least one comment. I'm getting all items. Article with comment class. I'm counting them and checking that they are greater than or equal to 1. That there should be at least one comment. Let's check out what happens when we run this. Obviously it fails. Let's implement it. I open the post show template. And below article I create a link with ID comments, which will be pointed to from the post's index when we click on some comment. This way we'll go directly to the comments zone. Below, I add an H2 with the identifier comments plural. And then we implement the for loop. I include a partial inside from the core bundle. Post, and I'll call it comment HTML tweak, passing the current comment. I'll create that partial. And that partial will have an article with class comment. It will have a header containing a paragraph with the text on. Translate it and capitalize it. We'll add a time tag. And here we'll put the comment created at, formatted to the ISO standard, which we saw before. Then we'll display the comment created at, but this time using the default format, depending on the current language. Next, we'll put the by with the author name. Below the header, we'll put another paragraph with the comment body. And we'll append a new line to BR filter. This will be the partial. Let's translate some items. Above the by, we'll put the on, doing the same for the Spanish version. Below the post, we create a comment. Plural comentarios. And here comment, plural, comments. If we run the test suite, they pass. So we know that our code is correct. Let's check it out in the browser. I'll open the first one. And here we have our comment. The second one. And the third one. In fact, there wasn't any need for this visual test. It's only to check out how it looks like, and this way we can see some things. Like for example, below the owned by someone, there's too much space that we must fix with CSS. It seems also that author is not being translated. If we take a look at the translation file, the author identifier is being used twice, and it seems that when reading a YAML file, it keeps the last one. So I'll move the author inside a new identifier named title. Now in show, instead of author, it is author title. Let's check it out. Update. And now it's working well. To fix the comment margin issue, we must open the CSS. We'll add a new entry just here. In the show article, we'll set a margin bottom of 50 pixels. In the comment paragraph, I disable the top margin. Let's check it out again. Update. It's not working yet. It seems that it's not loading the latest changes, so I'll install assets again. I'll try again. And now it works. It's looking better now. Now that comments are visible, I'll add the link I was talking about from the posts list. Below the by, I add a slash and then a link that points to the post show. Here I'll use a new tweak statement, that's the set, and it's meant to initialize a variable, a counter in this case. I get all comments from this post and I append the length filter to count them. Once I have it, I use a new identifier, post comments. And here I type the filter trans choice and I pass the counter. Let's see how to translate this. I open the English and Spanish versions. And below the by author, I type comments. I put quotation marks to avoid mistakes when parsing the document. And for the no comments case, I display no comments. I separate with a pipe. For the one comment case, I display the count value and I append comment. And in case of between more than 1 to infinite, that's what inverse square bracket does mean, because it doesn't include 1, I display the count value as well and I append comments. And just the same for the Spanish version. That's it for the translation. Now we'll get the root for the post show. I already have the root in some file, but let's practice this list. We have it right here. We must pass the Slack variable. So here in the href, I use path, passing the copied root, and the Slack will be post Slack. Then here I'll concatenate the comments identifier to jump directly there. Here we can see the links. Each post has one comment. If we hover, we see it's pointing to comments. Let's click on it. We see the URL contains the comments reference, and here it's redirecting correctly to comments. But this is all the browser can scroll down at this moment to show the comments zone. To finish comments, we'll create a form to create a new comment. To do so, we'll first implement a test. We'll name it test create comment. I'll get a part of the previous test code. Where I get the client, I get the first post, and I access to that post. The next thing will be getting the form button. To do so, I use the select button method, and I access to the text shown by the button. The form will be the call to the form, and let's fill it up. The form will have first the application name, the entity bundle name, and comment. The first field is author name. And we'll set the value a humble commenter. We'll do the same for the comment body. And for example, we said hi. I'm commenting about Symfony 2. We use double quotes. Next, we submit the form. And now we can begin to check. The first thing to check is the response, in particular if there is a redirection to the post. In case there's not, there was no redirection after submitting the form. Then we follow the redirect, in case there's some. And to finish, we'll do another assert. In this case, let's count there's one. Comment. To get the comment, we access to the source code, HTML contains, and we'll check the created comment message. We'll implement the create action, and then we'll display this message. Your comment was submitted successfully. And in the other case, there was not any confirmation message. If we try to run it, it has to fail because it's not implemented yet. It's saying that in line 63, it cannot find the node list. That's what we are searching for. If we look at the line 63, it corresponds to the form. It cannot find the form because it cannot access to the button we set. When developing a form, we must develop the form type first. That's the class containing all information about that form. To do that, Symfony 2 offers a generator. In this case, it's generate doctrine form. This form will be linked to the comment entity. Back to the code, we open model bundle. We see we have a new form directory, and inside we have the comment type. This is the generated code from our entity. Let's clean it. The first thing to do is to clean the fields that the user doesn't need to enter. Two of them are the dates. The author name, as well as the other fields, can get a second parameter, which we'll set to null in order to be auto-detected. But we can pass some field type that we need. Why did we set it to null? Because we need to set the third parameter. It will be the label. We have just set a translatable identifier that we will add later to our translations file. We'll do the same for the body, and we'll finish with the button. We'll delete the post because we'll do it from the code. We set a button. In this case, we'll set a submit type because the button doesn't belong to the entity. And we'll set the send label. We'll leave all other parameters as they are. Set default options defines the entity that this form is based on, and get name returns the unique name for this form, as all must have a unique identifier. To finish, I'll inherit docs. Let's add translations now. Name, name. Send, send. And comment singular, comment. The same for the other version. Now we go to the post controller, in particular to the show action, and just below the if, we'll create the form getting the information from our form type. To do so, we use create form, and we'll use our new comment type. This is sent also to the template. But what we send is not the form object itself, but the generated view from it.